My life be like, yeah. My life be like, yeah.
Hi, welcome to Chemistry with Mark Schiller. I'm your host, Mark Schiller. We have a great show lineup here today. We have Alex Galvin here, who's a great tennis player and a lead chemist. We also have Matt Damon talking about his movie Green Zone. Without further ado, Alex Galvin! Real pleasure. Thanks for having me on the show. So, how do you like Northern California? How's it been treating you so far?
I really like it. I know there's great weather, great food. It's awesome being by the beach too.
Yeah, that's pretty cool. So what really inspired you to be a chemist?
Well, when I was growing up, I lived in a harsh household, but there was a lot of chemicals around the house. We had bleach, we had Windex, and I decided, mix them up a little bit. And at the end of the day, I said to myself, I want to be a chemist when I grew up. So when I went to college, I got a degree in chemistry, and now here I am today.
It's a very, very good story. Thank you.
Yeah, no problem.
So, what's up with your lab experiment? What are you trying to do there?
Well, today I was planning on doing an experiment to test the solubility of water at different temperatures. Should be pretty exciting.
Very exciting stuff. So, how are your relationships going?
Gonna have to pass on that one. Well, let's get to the experiment, Mark.
Yeah.
Here we have warm water and cold water. We will attempt to dissolve sugar inside of them to see what happens, which will dissolve quicker and what will happen. Here we are prepared for the worst. Galvin is wearing his lab apron, his gloves, and his goggles in case anything terrible happens. I myself will step back as we attempt this experiment.
Galvin is putting the sugar inside the warm water. And now the cold water. And it looks like... Well, head chemist Gal, what does this look like?
Well, it seems as though, as I stir, there's much less sugar. Sugar is starting to dissolve in the warm water, but when I stir it in the cold water, yeah, it's really not dissolving here. What do you think?
Well, I don't have to agree with you, chemist, because I believe the warm water allows the particles to dissolve faster, whereas the cold water has the sediments seep to the bottom. Hey chemist, which one of these is a colloid solution?
Well, as we can see, there's very little sugar left at the bottom of this one, the warm water. And there is still much sugar left in this one, the cold water.
Residue. This program is brought to you by
Curling, bringing you earth-shattering entertainment for centuries.
Thank you. Thank you very much. Thank you. Wow, that was really a great lab. Really fun time.
It was really good, wasn't it?
Yeah, that's so weird though. Why did the sugar dissolve quicker in the warm water than the cold water?
Well, Mark, it's because the warm water has a much higher kinetic energy than the cold water does. This high kinetic energy separates the molecules so they move faster and dissolve quicker, unlike the cold water, which has a much lower kinetic energy and slows down the molecules so they don't dissolve as fast.
That's very interesting. What's kinetic energy?
Well, Mark, kinetic energy...
No, like with roller coasters.
Oh, roller coasters. Well, Mark, say you're going to Great America like you always do.
Yeah, it's true.
Going on the biggest roller coaster there. It's probably pretty high up, right?
Yeah.
So, as you go up, you really don't have that much kinetic energy because you're going, you're going really slow and stuff. But as you get to the top and start going down, you speed up and gaining lots of kinetic energy.
Yeah, that's what I like. So, what are you doing later tonight?
Probably hit up some clubs, you know what I'm saying?
I know what you're saying, man.
Alright.
Alright, thank you. Thank you very much. It was a great show. Oh, wait. I'd like to thank Ms. Rockman for letting us use her lab. It was really great. Thank you so much. Good night.